what's happening here? We're going to talk about the chain rule. Okay? It uses the idea of composition functions. Okay? What is a composition?
One function within another function.
A function inside of another function. So on your quiz, you had, what was it? 2x plus 4. Where 2x plus 4 is inside of something squared, so x squared. So it's a composite function. We have a linear function inside of that quadratic. Okay? We're still going to have to know all of our rules from before, but it's going to make taking derivatives like this much better. Okay? Because what did you do on your quiz? You multiplied it out into the power rule. Okay, we could also write this as binomial times binomial and do the product rule. Okay, the chain rule is going to save the day. All right, so what is the chain rule? So first of all, this is what we have. G needs to be differentiable, F needs to be differentiable. Okay. We have the composites. F composes G. To take that derivative, we're going to take, I'm just going to have you write this down. How about that? And then I'll talk about it. Because me talking and you writing is not going to be effective. What you need is what is down below. Okay. You don't necessarily need to write all of this sentence down. Okay, you can read through it, but what you need is that bottom portion. So what's happening? We're taking the derivative of a composition. We are going to work outside to inside. Okay? So first, we're going to take the derivative of the outer function, leaving the inside function in there. And then we have to take the derivative of whatever function is on the inside. Okay, so you're going to have to do derivatives a couple times. Okay, first with the outside function, then with the outside function, or the inside function, excuse me. So derivative of the outside times derivative of the inside. It will make more sense when we see an example, okay? But I need you to remember derivative of the outside times derivative of the inside.
So how do you find the derivative without manipulating the function side?
I will show. Should we look at the example I was talking about while we're still on this page? So on the quiz, I asked you to take the derivative of 2x plus 4. Okay. 2x plus 4, the quantity squared. What function is inside?
2x plus 4.
2x plus 4. Our outer function is x squared. Okay? Because we're taking this and we're squaring it. So we are going to take the derivative of the outside. We have something squared. When something is squared, we would use the power rule. Drop the power and decrease the power by 1.
Okay.
Drop the power, decrease the power by 1.
Oh, so it's like 1 out. There's basically 1 in front of the 2x plus
Right, this is like, okay, so what I took the derivative of was x squared. Except instead of x, there's something inside. But I have something inside, so now we have to take the derivative of the inside. What's the derivative of the inside? 2. So our derivative is 4 times 2x plus 8. So, or, excuse me, 4 times 2x plus 4. Okay. A much quicker way of taking that derivative, do you agree?
No, I think the other one's way easier.
Yeah, true. Well, unless it's more complex, like.
Yeah, if it gets like more complex, but like that, I'd much rather just apply it out in power.
Okay. Yes, Jim.
So if it was if it was cubed, would it be three for that, then to the second?
Okay, so let's ask a question. If I asked you to take the derivative of 2x plus 4 cubed, then our outer function is x cubed, so we would do the power rule. Okay, times the derivative of the inside would be 2. That would be, you don't want to multiply 2x plus 4 to the third power,
Yeah.
right? So, okay. This would also be nice if I asked you to find points of horizontal tangency and you have to set it equal to 0. Here it's already factored for you to set equal to 0. Okay, so there's going to be some benefits. All right, so, all right. We're all about examples today. Okay? And the only way you're going to get better at this is if you practice. So, what is our outer function? Cosine. Inside of cosine, we have x squared plus 9. So when we take the derivative, we need to take the derivative of the outside function, which is what? Negative sine. Leaving the inside function alone. It still has to be in that derivative. Then we can multiply by the derivative of the inside, which is what? 2x. So I would probably rewrite this to negative 2x sine of x squared plus 9.
That's just the answer, like that's something you gotta do with it.
Yeah.
Okay, it's gonna get hard with it.
Can
go work.
It's gonna get hard.
When you guys complain, all I hear is me, 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 me. You did not get my reference to Snoopy? Thank you. Thank you. Thank you. Or is it wah, 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 wah? Right? Okay.
It's like 10 minutes.
What's our outer function? Sine. What's our inner function? 2x. So the derivative. What is the derivative of our outside function?
Sorry, cosine.
Cosine. Our inside function stays with it. Times the derivative of the inside. So our derivative is 2 cosine of 2x.
So what would you do if you had something like?
Derivative of sine, that's what makes sense.
2x plus 3. Would you angle and then
the derivative of the inside would be a product. Okay? We might, if we have time, we'll look at one like that, okay?
Yeah, please.
Oh, that. Oh, man.
you gotta rewrite it first.
Okay, so someone said, oh, we need to rewrite it. Is that a good idea?
5 minus 3x to the 1/2.
So we can rewrite this as 5 minus 3x to the 1/2 power. And that would help us so that we can use the power rule with the chain rule, right? So our derivative, what is our outer function? Whatever to the 1/2, right? X to the 1/2. So when we do that power rule, it becomes 1/2. And then decrease our power by 1. Multiplied to the derivative of the inside would be -3. So our derivative is -3 over 2 square root of 5 minus 3x.
Dude, you're sassy for
Okay, one more simple one. One more simple one.
Homework.
What's our outer function?
Oh, this one, yeah.
Tangent, what's our inner function? Square plus 1. So, derivative of the outside.
Secant squared.
Ooh, some people did their homework or memorized them. Thank you. We leave x squared plus 1 inside times derivative of the inside.
What about the x?
Oh, sorry. I got to thinking about something I wanted to talk. Yes, minus 2 points.
X. So it's about secant squared x times x squared plus 1.
Oh, I had an issue. Issue is fixed.
If I miss these questions on the test, I'm gonna tell you that it's because I was top copy.
Actually, I made those mistakes so you could point them out and fix it, and now you're not going to make them.
Oh,
Oh, man, it wasn't.
Why are we doing it?
Oh, thank you.
Wait, so would the x still be in there though?
Yeah, because the 2x is the.
2x is the x. Technically.
Excuse you.
Oh,
Product rule.
Thank you. I need you to recognize that this is a product. This is not a composition. We would have to use the product rule on this. That was a very intense shake of the head. Okay, this would need the product rule because it is a product. Okay. It would be what?
To be cosine.
The derivative of the first times the second.
Minus sine.
I felt so good. Oh.
Right? First times the derivative of the second. All right. New one.
Need to go back.
oh, quotient
Yes.
All right, good.
What is it?
Just kind of learning this.
But you're waiting till like the last day. Derivative of the first times the second plus the first times the
I
derivative.
thought you were just saying the derivative of x.
All right, So what are we working with here?
Quotient.
We're working with a quotient. Okay? Now, you cannot simplify that. We
No, I
cannot,
mean, like the bottom, could you?
But x squared is equal to 2?
nope.
Square root of-
You cannot break up a radical by multiple or by addition or subtraction. You can only break up radicals by multiplication and
Well,
division.
no, what I was asking is, since it's the square root of x to the fourth n plus 2x squared, or not 2x squared, 2 squared, couldn't you? No?
Nope. Now, if it was the square root of 4x to the fourth, that would be 2x squared. But addition, can't do it. Okay? So, but I would probably write this as x over x to the fourth plus 4 to the 1/2. Right? Okay. So our derivative. Please exercise some patience and be careful. So first of all, we need low, d high. What's the derivative of the numerator? 1. Minus high, d low. So numerator times the derivative of the denominator. We have a composition. So the first rule we're going to perform is Okay, we're going to do the chain rule. So the outside, we have a power of, so we have a power of 1/2. Right? So there's the power rule times the derivative of the inside. So the derivative of the inside is 4x cubed. Okay? So that's high d low all over low squared. Do that. Right?
Oh, is that because the half is squared? Well, we have to simplify that now.
Now, this is what I would be worried about you getting to. Okay? However, let's go through the process of simplifying it so that if this were ever a problem you had to set equal to 0, you would know how to do that. Okay? Okay, hey, you all need work on your algebra skills. Here I am, gonna go through it step by step with you. So do you notice how x to the fourth plus 4 to a power, x to the fourth plus 4 to a power? Okay. Now, they have different powers. Do you agree? What I'm going to do, because negative powers are kind of uncomfortable, I'm going to factor out the negative power. So if I factor out x squared plus 4 to the negative 1/2, if I divide it out of this one, what is the power that's left over?
1
Right? Okay, so I'm factoring out x to the fourth plus 4 to the negative 1/2 so that I don't have a random negative power in the middle of all of this. So I'm factoring this out. Since we have the same base, we just, okay, I'm looking at the exponent. So if I want to multiply this back through, when we add our exponents, we get back to here.
Okay. So why is that 1 then?
Because I have dividing and subtracting.
Right, so we're dividing this out of
Okay,
each of
yeah.
these things, okay? So since we're dividing it out, we took 1/2 minus negative 1/2,
Yeah.
okay? So now over here, we're left with x times 1/2. This gets factored out times 4x cubed. So we have 2 x to the 4th. Okay. So now what do we have? You notice how this is x to the 4th plus 4 to a negative power, which means we can bump it downstairs. But this is also x to the 4th plus 4, technically raised to the 1st power. So when we take that negative denominator, or negative exponent, and move it to the denominator, we get x to the 4th plus 4 to the 3/2 power. Okay? And then upstairs, we would have negative x to the 4th plus 4 when we combine like terms.
Would it be for the denominator, would it be negative 3/2 if you were subtracting?
No, because when we move this downstairs, it becomes a positive exponent. So we have 1/2 plus 4. X.
And then how does that 2x to the 4th just disappear?
It did it. X to the 4th minus 2x to the 4th would be negative 1x to the 4th.
What about the plus 4x to the 3rd?
Well, I'm just confused because you took the x to the 4th plus 4 to the negative half and you factored it out, but
But what? So like out of this whole thing here, that's this right here. So when we factored it out, that was left to just be 1.
then what about the first one?
The first one, when we factor it out, we're left with the same thing as the first power. Because when we take this times this, we would add our exponents to get back to the 1/2 power. Because so when we divide out the negative power, we had to subtract negative 1/2 from this to get this.
You could just
Can you
combine stuff, yes.
Yeah.
Okay.
Without factoring?
Well, you can make a common denominator out of your numerator terms, because this is really a denominator, right? Because it's a negative exponent. Yes, you can do that.
So that's what I was trying to figure out. Like,
Yes. Yes. Okay, yes. You could say that this is 2x to the 4th over the square root of x to the 4th plus 4, or make a common denominator and squish those together. I was just showing you a technique, okay? Are you going to have to do this in your homework tonight? Probably not.
Okay.
Okay.
this is-
Could you have to do it later? It's possible. It's possible.
Oh, great. Another one.
Is this a composition function? Excellent. With a quotient inside. So,
Can't we just times 7 rows together?
yeah, because that would be,
Quicker.
I don't think it would be. Okay, so outer function is x to the 7th, and how do we take that derivative? 7 times whatever's inside raised to the 6th power. Times the derivative of the inside. You told me the derivative of the inside is going to be the quotient rule. So we have low, what is d high? 2 minus high d low. 3. All over low squared. Okay, this algebra is not bad. Okay, we have 6x plus 10 minus 6x plus 3. Right? So we're left with 13, 3x plus 5 squared. Okay. We can make this look a little bit prettier, okay? And it's not difficult, so we're going to go ahead and do that. This is 3x plus 5 raised to the 6th power, and this is 3x plus 5 raised to the 2nd power. So do you agree that we have 3x plus 5 raised to the 8th power downstairs? Okay. And then we have 13 times 7 is 95, 2x minus 1 to the 6th. Not 95. 91. Multiply something. Huh? Okay, you're going to have to be careful. You're going to need to take your time while you're taking these derivatives to keep track of, okay, I took the derivative of the outside, now let's take the derivative of the inside, and keep everything organized right legibly so you can read your work. Yes.
So if we get to the point where we get it, but it doesn't look nice, and we can't figure out how to simplify it down, is it okay if we leave it like that?
This is probably okay for the quiz on Friday. Okay? If that's your question.
Can you just explain how you got to the 91?
That's 7 times 13, right? 7,
Yeah.
13.
Yeah.
Last question, and this is going to answer Zach's question from before.
No, it's good for a slightly easier answer to my question.
Can you just put everything into the denominator to make it positive?
Well, I think it would be easier like this so we can use the power rule for the outside function,
Oh.
right? Okay, so we have something to the negative 8th power, but there's something inside of that function, so it is a composition, right? All right, so let's take the derivative of the outside. Derivative of the outside would be negative 8 times blah, 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 to the negative 9. Now, inside, when we take the derivative, what's the derivative of 1? Okay, plus x to the 5th cotangent x. Product rule. So derivative of the first times the second plus the first. What is the derivative of the second? Good. We remember our rules. So our derivative, if we make this look a little nicer, negative 8 times, I'm going to rewrite that, 5x to the 4th cotangent x minus x to the 5th cosecant squared x. And then since this has a negative 9 as a power, I'm just going to put it downstairs with a positive power to make Carter happy. And that is probably what I would want to see as your answer. Okay. I don't feel like that's too much to ask. Right? Just reorganizing a little bit. What happened to what?
It's gonna be very hard.
Okay. Just be careful with your rules. Okay? Is there a product rule inside of your function? Is there a power rule inside of your function?
specialized.
Because also shots.
Could leave it like that, I think it was prettier as negative 4, but you know what I mean? But if you left it like that, Friday, but I would prefer it.
Hold on, please. I want to stop this.